Let's consider some questions involving exponential expressions. Our first question is 4 to the second power is what number? To answer this question, we would take 4 and multiply by itself. 4 times 4 gives us the answer, which would be 16. Let's take a look at a different question that looks at that same relationship but from a different point of view. Our next question says 4 raised to what number is 16? Well, we know from the previous problem that 4 to the second power is 16. So the answer to this question would be 2. Our next question says 3 raised to the fifth power is what number? Well, if we multiply 3 times 3 times 3 times 3 times 3, the result would be 243. So thinking of that, if we look at our next question, 3 raised to what power is 243, we know from the previous problem that the answer would be 5. Often we're used to knowing the base and the exponent and trying to figure out what the answer would be. What we're going to be focused on in this chapter is knowing the base and the answer and figuring out what the exponent should be. What should be the exponent that we raise the base to in order to get the desired answer? When we're evaluating exponential expressions, we raise a number to an exponent to get the answer. The inverse of an exponential operation is going to be what we call a logarithmic operation. And to evaluate a logarithmic expression, this is where we're answering those questions, where we're trying to find the exponent. When we have an expression written like this, log is an abbreviation for logarithm. 2 is written in a subscript. 2 is what's called the base of the logarithm. And we're doing the logarithm base 2 of 8. This expression is asking us to answer the question 2 raised to what power equals 8. We know 2 is the base, 8 is our desired answer. We're trying to figure out what the exponent should be. Now 2 times 2 times 2 is 8. 2 to the third power is 8. That means our answer for the logarithm base 2 of 8 would be 3. So if we're looking at something like the logarithm base 10 of 1,000, to evaluate such a logarithmic expression, you think about the base and you think, what power should I raise 10 to in order to get 1,000 for my answer? We're thinking 10 to what power is 1,000? How many 10s do I multiply together to get 1,000 for the answer? Now 10 times 10 times 10 is 1,000. So 10 to the third equals 1,000, which means our answer here would be 3. If you'd like to try the next 2 problems on your own, pause the video now and resume when you're ready to see the solution. Thinking of logarithm base 3 of 9, the question that we're asking ourselves is 3 raised to what power equals 9. A lot of students make the mistake of thinking logarithms are division. They're not. They're the inverse of exponentiation. So here, 3 times 3 is 9. So 3 squared is 9, which means the logarithm base 9 would be equal to 2. And if we're thinking of the logarithm base 3 of 27, 3 times 3 times 3 is 27. So 3 raised to the third power is 27. This means that the logarithm base 3 of 27 is 3.